right, so we've got bivariate data. We're going to investigate the relationship between hours spent cooking and the number of birthday cakes. A sample of 10 shops were taken. The table below indicates the hours spent cooking over the number of cakes made by each shop. So we probably are going to be looking at or trying to work out how many cakes the shop makes. So that would be this one would be what we're trying to predict. So therefore this one will be our RV, or often our Y value. Okay, and then the number of hours cooking will be our explanatory variable. So when they asked us each which is the explanatory variable, it'll be the number of hours, and which is the response variable. So we're then asked to create a scatter plot. So when we have a scatter plot, obviously we need to put the two lists into our calculator. So I suggest that you use the names that they've used, so it's easier when you're checking over in an exam and you don't have to delete your list because they'll all have different names. So we're going to say hours, and you could say cakes or birthdays, whatever. So you've typed your lists in, and you've gone to data and spreadsheets, and you've gone to and done the scatter plot. So remember, along here you select your RV list, and down here you select your EV list. Now here I've put the regression line on there. If you want to put that on while you're on this page, you can press menu, sorry, I didn't pause. So it's menu, analyze, and then you want the regression, and then you choose A plus B x1. Okay, so that's if you want to get the equation, the line on there, so that might be helpful. Okay, now it's asked us to describe the relationship between the number of hours cooking and in terms of strength. So the strength is where we look at the R value. So over here I've got it, it's 0.88, so that is a strong. The direction is a positive, it's going up, yeah? So you can just write strong, positive, and it's following a straight line, so the form is linear. Okay, now it asks me here to determine the value of the Pearson's correlation coefficient, which is R. So R equals, and I've got that there, 0.8. I'm just going to do 2 decimal places, 89. Then it also asked me as well to find the coefficient of determination, which is R squared. So I'll just write that to 2 decimal places as well. So I'll write 0.79. Okay, I've asked you now to interpret the coefficient of determination. So we saw before, we know the coefficient of determination is R squared. So if they ever ask you to interpret or meaning explain what it tells us or something like that, you are going to go and use this little template, which you have in your reference books, and I believe it's on the back page. So what we have to do is, I had the wrong explanation. It was this one. This one is it within your notes under R squared when we talk about it. So if you're asked to interpret it, you just have to interpret it in terms of this scenario. So I'm going to write this out. So I would write the coefficient of determination tells us, so you just write all this. I'm not going to write it out. I'm going to use this template. But you would write this out. So you see it, it's down here. So you'd write this out, tells us that. Now this in the yellow is where you're going to change it. Now our R squared value was, R squared was 0.79. So what you need to do is times that by 100. So I'm going to say that it tells us that 79%, and then I would keep writing what's here of the variation in. Now, I would change this, and I'm not going to write this. I'm actually going to put what the response variable is. So what was the response variable in this? Was the number of cakes, wasn't it? Yes? Number of B-day cakes. So I write that in there. is explained by the variation. Now, it wasn't, we don't want the explanatory, but we want to put what it was, which was the number of hours. Was that true? Yeah? So you would write that out if you're wanting to. Now, the other thing to to take note of is obviously when you see the variation in, so if you see that wording, they're talking about R squared. So, we saw it before. They said, what percentage of variation is explained? It's just they're asking you, what's the R squared as a percentage, all right? The question didn't on your sheet, it didn't ask you to write the regression line, but this is a big part. Of course, you're going to write your regression line. So we know that our regression line follows this pattern, y equals a plus bx. Now, we don't write y, we have to write what it actually is in the scenario. So for us, it's the number of cakes, and then we'll write equals. Now, we need the a value, so okay, so we need the a value. I'm just going to do 2 decimal places. So it'll be 42.25, and then I'm going to get the b value, which is a positive, plus 2.09 times the number of hours. Okay, so there's my equation. That was the a value, that was the b value. Now when they ask you, use the line to predict the number of cakes, that's where we're going to use this formula. So for this first one here, we're going to do, all right, the number of cakes would equal, and then you just use your formula. So it'd be 42.25 plus 2.09 times 22, and you'll get an answer. So let's go do that on the calc. And then the one for under, the number of cakes when it's 16 hours, we do the same thing, but we times it by 16. So we'll go do those. So we're not going to have half a cake, so we'll round to a whole number. So when I do this, I get 88 cakes for this one. And then when I do 16, I get 75.7, so I'm going to round to a whole number. So I'm going to say 76 cakes. Okay? Now, what happens here, the next thing they ask, when we made, these are called, we're making predictions. So these are when we're making predictions, yeah? So when you're making predictions, they often ask you whether it is interpolating or extrapolating, okay? And it's all to do with the x value that you're using, yeah? So the x value you're using. So let's go have a look. I've just put it on the next page, so we'll go have a look. So if you're predicting anywhere within the range of your dots. So can you see, like I have, my lowest one was like 9 hours and my largest one was 20 hours. So anywhere between 9 hours and 20 hours is called interpolating. Yeah? This is interpolating. Okay, so that's interpolating if you're testing. If you test out here, so anything, say, less than that, so less than the 9 hours or more than the 20 hours, that is called extrapolating, okay? So it's because you're out of what you recorded. So trends could change. Something could suddenly happen once you hit. So we need as data when we tell people we're making a prediction, but interpolating is pretty reliable because you've seen data around that area. Extrapolating, you need to let people know that, well, we're predicting that the trend was the same when we couldn't see it. So if we go back to, when we go back to our predictions, we had to predict when the number of hours equaled 22 and the number of hours equaled 16. So what was 22? Is it interpolating or extrapolating? Good, it's extrapolating. And what is the, oh, sorry, I wrote 22 there. Sorry, what was 16? Was inter, wasn't it? It's in here, yeah? So that one is interpolating.